Hi all, let's go ahead and get started with today's notes. We are going to be talking about polynomial functions. When we are dealing with polynomial functions, remember to first write them in standard form, which means our highest degree first. Okay, and then pay attention to the leading coefficient. The leading coefficient is the value in front of the term with the highest degree. So here, if I had x to the fourth, okay, and plus ax to the third plus ax squared, and it could go on, plus a constant, okay. We could have ax, let's do that anyway. Add ax to the first, or just ax, and then plus a constant. The term with the highest degree, that's my leading term. My leading coefficient is the value in front of x to the highest degree, okay, or m to the highest degree, or p to the highest degree, whatever variable we're using. In this case, we just happen to be using x. So right here, it has f of x equals a sub n x to the nth power. A sub n, x to the nth power, is their leading term, and a sub n is going to be their leading coefficient. So again, the leading coefficient is always the number in front of the term with the highest degree. Although all these a's are coefficient, I'm only looking for the leading coefficient to help me out with today's notes. All right, so I'm going to be looking for the leading degree, or the highest degree, and the leading coefficient. Okay. All right, one of the things that I also like you to remember is x, or anything to the 0 power besides 0. 0 to the 0 power is undefined. But if I have 1 to the 0 power, or 2 to the 0 power, or 99 to the 0 power, or negative 32 to the 0 power, anything to the 0 power other than 0 will always equal 1. Okay, so when you don't see a degree there, the degree is always understood to be 0. Okay, so for example, on this first one, f of x equals 4. Well, there really is an x to the 0 power. Okay, but that's the same as saying 4 times 1, because x to the 0 power would make 1, which gives me that constant value of 4. Okay. And that's exactly what they had here, was the constant value of 4. So the degree on this one is 0. Okay. Our leading coefficient in front of x to the 0 power would be 4. And in this case, it just happens to be referred to as the constant. Okay. All right, on this next one, negative 5x to the first. The leading degree here, it's understood to be 1. So the degree is 1. The leading coefficient in front of x to the first is negative 5. On this next one, our leading term on this one is 12x squared. Our leading degree is 2, and the leading coefficient is positive 12. On this next example, our leading term is negative x cubed. Our leading degree is 3, and our leading coefficient is negative 1. Then we've got on this next one, our leading term is negative 3x to the fourth. So our leading degree is 4. Our leading coefficient is negative 3. On this final example here, we've got our leading term is 9x to the fifth. The leading coefficient is 9, and the leading degree is 5. Okay, based off of the videos that you guys watched yesterday and the one that I posted before this where we talked about how the degree affects the end behavior. Remember, if it's an even degree, the ends will point in the same direction. If it's an odd degree, the ends will point in opposite directions. So looking at these degrees here, if it's a degree of 1, they are going to point in opposite directions. If it is a degree of 2, they're going to point in the same direction. Degree of 3, opposite directions. Degree of 4, same directions. Degree of 5, in opposite directions. Okay. Now the leading coefficient is also important to us because it tells us where the right side of the graph is going to end up. So if it is a -5, the right side of the graph is going to point in the negative direction. Okay. If it is a +12, the right side of the graph is going to point in the positive direction for the y value. If it is a -1, it is going to point in the negative direction. If it's a -3, the right side is going to point in the negative direction. And +9, the right side is going to point in the positive direction. Okay. Looking at these values here, we can see what's going to happen on the other end. Okay. So they're going to be opposite directions on the left side. This one's going to be the same direction on the left side. This one here will be the opposite direction on the left side. This one will be the same direction on the left side of the graph. And this one will be the opposite direction on the left side of the graph. Okay. All right, so let's go through and look at some functions and some graphs. Again, this was based off of yesterday's video notes as well, so you should have this in your notebook already. But let's go ahead and add that to this worksheet. Okay, so if I have something that is a constant, we would have f of x is equal to c. Constant for y equals c, that is going to be a horizontal graph. If it's linear, so I've got f of x is equal to x. Remember, that's to the first power. It's a positive coefficient, a positive leading coefficient, so the right side's going to end up. Quadratic is f of x is equal to x squared. Okay, positive degree or even degree means they're both going to point in the same direction. Positive leading coefficient means that the right side's going to point up. If it's cubic, okay, both ends are going to point in opposite directions because it's an odd exponent. The right side is going to point up. The left side is going to point down. Okay. So if we have quartic, both ends are going to point in the same direction, and when it's a positive leading coefficient, because this is a +1, both ends are going to point up. And if it's quintic, x to the 5th power, it's an odd degree, which means the ends are going to point opposite directions. Okay, and the right side is going to be pointing up because so far the leading coefficient is a +1. Okay. All right, so let's go down and do some practice with these. I am going to do 2, 4, and 6, and I'm going to leave 1, 3, and 5 for you. Okay. All right, so focusing on 2, 4, and 6. All the two pieces that I need can be found in the leading term. So for this one, our leading term is -x squared. Okay. looking at that leading term, my degree is 2. So when it's an even degree, that means that both ends are going to point the same direction. Okay. Now the leading, whoa, what just happened there? The leading coefficient, on this one is -1. So with a -1, that means that the right side of the graph is going to be pointing down. The left side of the graph is going to point the same direction, so it's also going to point down. Okay, so as the x value increases, so as x values are getting bigger, what is the y value doing? Well, that is going to -infinity. Okay, and remember in this case, when they have the same degree, the left side is going to do the exact same thing, so it is also going to go to -infinity. Okay. Now on this next one, f of x is equal to -x cubed. Okay, looking for our leading term. Well, there's only one term, so that one is our leading term. Okay, and the leading coefficient is -1. That tells us that the right side of the graph is going to be pointing down because it's a negative. The degree is 3. It's an odd number, so it tells us that the right side is going to be pointing in the opposite direction. All right, so as x goes to +infinity, so as x moves further and further to the right, what is happening to the y value? Well, in this case, it is going to -infinity. As x is going to, or coming from the left, where x was -infinity, the y is now the opposite. So this one will be +infinity. Okay. Odd degree means opposite ends. That includes these two are opposite. That was negative, that is positive. Okay. This last one, they were the same. So they were both going to -infinity. Okay. So let's look at this last one that we're going to be doing here. So I have 1/2 x to the third. Okay. So my leading term is the one with the highest degree. Okay. And on this one, I can ignore that +7 because I only need this leading term. Well, 1/2 is a positive number. So that means that the right side of the graph is going to end up pointing to the positive direction for the y value. Okay. The degree is odd, which means the left side is going to point the opposite direction. All right, so as x continues to +infinity, the y value also goes to +infinity. These are going to be opposite. So if it's +infinity, then that means this other one has to approach -infinity. Okay? All right, so 1, 3, and 5 are yours for your independent practice, and 7 and 8 will be your independent practice, but I want to finish up this last chart right here. Okay? If we have a leading coefficient that is positive and an even degree, a leading coefficient that is positive means the right side of the graph is going to always point up. Okay. If the leading coefficient is negative, then the right side of the graph is going to point down. Okay. Remember, we read left to right, so we finish up on the right side of the graph. That's why I'm always graphing the end first. Okay. If it's an even degree, they are going to be the same direction. If it's an odd degree, the ends are going to point opposite directions. All right, 7 and 8, that is yours. I want you to determine whether the leading coefficient is positive or negative, and then if the degree is odd or even. All right, now I will talk to you all later. So once you're completed with this, go ahead and find your quizzes assignment for this evening.